Welcome back to Ox Tools. I'm Tom. Hi guys. We got a little job here. We're helping out Greg at Seattle Precision on a little job. He's got a large stamping press or forming press that he does drawing dies for, and does some punching and things like that on that press. He does secret parts for Boeing, I guess, so we won't get a look at any of his parts, but he needs a little bit of help. What we're doing for him is he needs some heavy-duty heat-treated pins for his quick change die setup, and we talked about materials to use and what would be appropriate and etc. So I suggested 8620, partly because I have some, and it's a good material. If you're not familiar with 8620 steel, check it out. It's pretty good. It's weldable. It carburizes and case hardens well. It machines excellent. It's just a nice material. Anyway, so these pins will be heat treated and carburized, and have a case hardening of maybe 40 thousandths, about a millimeter case depth. That's a millimeter on the radius, so that's a pretty deep case. You can get up to almost 2 millimeters case depth, and it's just time and temperature is the main difference. So one of the reasons I suggested the 8620 was I have a little project that's been kind of languishing here that needs some heat treating, and it happens to be made out of, guess what, 8620. So I can make a decent batch for the heat treater with my parts and Greg's parts, and they'll all be treated the same, and so it makes I guess a better minimum charge or minimum lot for the heat treating. So these are here. I got a drawing of that's what Greg's pins look like there, and they're pretty simple. They've got a couple of precision surfaces on them, because when he sets the dies up, there's some height issues that have to be held pretty closely, and then the diameter of the smaller part here has to be held pretty close too. Now, I don't really want to grind these after the fact, so we have to anticipate a little bit of growth with this particular steel. Since we're adding carbon to the surface of the material because it gets packed carburized as a heat treatment process, we have to anticipate that a little bit. So what we're going to do is machine it a little bit smaller than what we want it to be after the heat treat because it grows. And on a 1-inch diameter with that particular 40 thousandths case depth, we might expect anywhere from 6 to 8 tenths growth, something like that, 10 thousandths of an inch growth. So what we'll do is we'll be about 8 tenths under the target, something like that, and that way we don't have to do any post grinding or anything like that on these pins. Now, my project that's sort of going along with this one here, it's already been machined, and it's just been sitting around the shop waiting to get heat treated. And what they are is, and I'll show you here. These are cylindrical squares. And you can see on the bottom they have some features there, some dust notches and some holes, some kind of lightning holes, and they're both very similar. Anyway, so I machined those a while back, and they've been sitting around. These are 8620. So the idea here is they have centers in them, and what we do is we get them heat treated, and then what we do is we grind this cylindrical diameter here very smoothly and very accurately, and then come in on the side with the grinder in the same setup, and we grind this end surface. And it's narrowed so that it grinds really easily. Same here on this end, and we'll do both ends. So the idea is this cylindrical diameter has no taper, or as little as we can get, and then this end surface is perpendicular as close as we can get it with grinding, which is generally pretty good. So the idea is these sit, can you see that? Yeah, okay. Let me back up a little bit. So they sit on the surface plate like this, and then what you use is you use a squareness comparator, and I made this one a while back, and there's a blog article on this, and normally you would do this on the surface plate, and the idea is that you set this the squareness comparator here with the cylindrical square, right? This is a known square, and all this is doing is comparing this radial surface here down here with this indicator point right here. And what you can do with that is now you can very, very precisely check blocks and other objects with this, and it's adjustable back here. It has a flexure that allows you to tune the position here. So anyway, that's what these are about. And you know, if you're going to make one, you know, obviously this is a pretty simple machining job for the rough machine work. Excuse me, and the grinding work takes a little while longer, and but once you're set up, you know, it's pretty easy to do 2 of these, and then I don't really need 2. I barely need 1, but I might as well make 2, and maybe I'll trade 1 or do something like that later on. So anyway, right now we're gonna help Greg with his pins, and so we got some lathe work and some knurling. Everybody always likes knurling, so we'll show some excuse me, some knurling, because he wants the large diameter knurled here. So yeah, let's go do some lathe work. All right, so we're over on the lathe now, and we're getting set up to do these press pins for Greg up in Seattle. So here's our starting blank. This is what I had. It's 3-inch diameter, 4-inch long, 86/20. So we got to do a little ripping and tearing to get down to these pins. I just happen to have a whole bunch of this material left over from a scrounging mission. So anyway, that's what we got to work with. So we've got a lot of machining to do, so there's gonna be a lot of tool pressure and hogging. So what I like to do in this situation is the first step is on the gripping side. What I'm gonna do is I'm just gonna turn this diameter down, you know, 150 or 200,000, something like that. So what I get is a nice clean round diameter, and I also get a tiny little shoulder here. And you'll see what that's going to do here in a minute. When I flip the blank around, the jaws will grab it, and then that shoulder will seat against the jaws. So it gives me really good, it won't slip in the jaws going into the chuck, and I have a nice clean diameter that's been freshly turned, nice and round. No dents, no weirdness, no out of round, and so I get a really good grip on it. And then I don't, you know, it's clamping security is what it is. So we're just gonna spin a little off of that diameter here. I'm just gonna touch off. Touch off there, and looks good. Change the feed rate. See how that is. And this isn't a fuzzy dimension. All I care about is that it's round, and you know, I'm going to hold on to about 1 inch. That looks good. Face that edge. All right. So now flip that around, I'll flip that nice diameter around now, and that's what I'm going to hold on to. Okay. Okay, so I got a nice grip on it. I got plenty of material here. Got about 3 inches sticking out, teeny bit less than that. And all right, we'll get started. That's 250 on the diameter right there. I got plenty of room there. I'm just tearing off this material. So now I'm going to rough in that. I'll rough in the pin diameter. Now there's a 16th corner radius here, and this insert is sharper than that. So I got to leave a little chunk of material in there and use a different tool to finish that, so I can do that internal radius there. So we'll do that coming up here in a minute. So that's just a witness mark. So I know when I'm getting close to the So that's pretty toasty right now. We're going to let this cool off a little bit. We're 927. Probably go a little closer than that. Let's do that. Let's take another 50 off of that. stop right there. But just to give you an idea, I'm squirting a little bit of water in those chips, or a little bit of coolant. And you can see that's where all the heat went. Alright, we're going to let that cool off for a sec, and I'm going to get another tool. Alright, so we're going to find us a tool bit now in my tool bit collection. So I'm looking for one that's got a little corner radius on it. I don't want to have to grind anything if I don't have to. And after years of collecting tools, it's left-handed. So lead angle on it. You know, you should be able to have something that's pretty close. I want carbide in this case. I want it to, well, it doesn't really matter. Oh, here we go. That looks pretty close. I think it was a 16th radius. Got to get my old man magnifiers here. Oh yeah. Yeah, okay. Feels good. Okay, we're going to go with that one, or we're going to try it, see how it works. Okay, so this is nice and cool now. We can take some measurements and then finish this diameter for, or get it closer for the finishing tool, I should say. An interesting thing here, I'm going to pick up some of these chips. I don't know if the camera's picking up that color though, but take a look at that color. That's 8620. It gets this kind of bluish purple. It's very kind of a nice color. I always liked that color when you got nice hot chips there. Anyway, it's kind of a characteristic color of this material, or certain materials do that anyway. It's just kind of a purplish blue. Okay, so let's just take a quickie here. 880. So that wants to be around 7/8 diameter up to this little step here. And what did I say, 880? 885. So we need to take about 10/1000ths off of that, and then we can come at this with our finishing tool here. So let's come up. Oops. So that should be 7/8, or pretty close to it. 873, okay, that'll work. Okay, so now we're gonna, I'm not hitting the camera there. So that's that finishing tool that we were digging out of the toolbox over there. And I've already set the height. You guys have seen that before. So this is this 1/1000 shim stock. Okay. So now I can calibrate my tool. Come off of there. And I think I'm going to slow the feed rate down. Sure, why not? Now you can see the radius that it's forming there in the, on the leading edge. That's what we want in the corner when we get to our finish diameter. Eight, 10. Alright, let's use a micrometer here. Okay, so I got about 4 thousandths left on that. It's a little warm, so I think what I'm going to do is I'm going to come up into that corner and face that off a little bit and get it closer to my Z depth. I'm really not going to take any off of the diameter here. Actually, I'm just going to go right into the bottom in there. And come on out. Okay, so that's about 4 thousandths. Yeah. I'm just checking the temperature there. All right, 74975. Okay, I think I'm calling that good, eh? All right, so let's go. We'll bring it in, and then we're going to finish that shoulder. You saw me pulling on that a little bit, and what that does is it just puts a little pressure on the tool post so the tool doesn't drag over my finish diameter there as I came in. That's all that's for. And now we're going to go back and finish that and knurl that. Okay, so we've got our knurling tool here, and then so those are the knurls that can you see that? Those are the knurls we're going to use. These are crowned Accutrack knurling tools, and here's some other ones here. Straight knurls and then finer knurls. Now these guys here, these are diamond knurls. We got one right hand and one left hand. And what those are, let's see, let me get my Sharpie out here. Those are 16 TPI, so that's teeth per inch, okay, is what that means. So the diameter that we want to knurl on is around 2 inches, okay? So the first thing we do is we want to figure out what diameter we need to knurl on, okay? So what we're going to do is we'll just take our 2 inches, 2.0, okay? We're going to multiply that by pi, 3.1416 times. So 2 times pi equals 6.2832, okay? And then we're going to divide that by, or multiply that by 16, okay? And so what we get is we get 100.5312. Okay, so what that means is, that means there's 100.5 teeth in a 2 inch diameter. So that thing will track around there 100.5 times. Well, this is the part that's the problem. So what we want to do is get rid of that. This is what we care about right here, the whole number. Okay? So what we're going to do is we'll take that, push this back a little bit. So we're going to take that 100, okay, and we're going to multiply that, or excuse me, divide that by 16. 100, 16, divide. So that equals 6.25, okay? Now we're going to take that and we're going to divide that by pi, okay? 3.1416 divide. Now we get 1.9894, okay? So this is our actual, what that means is that's our diameter, okay, that our 16 teeth per inch will divide, track on as a whole number, okay? So that's our target diameter for turning for these particular knurls right here. And I showed this once before on the straight knurl, and you know, it's kind of the same thing. And so let's go ahead and turn that, and then you know, see how it comes out. All right, so I got this diameter turned to our 1989, which is our knurl diameter. So we're going to come up and knurl this guy right now. And so what I do is I come up and I set this particular knurling tool. There's a bunch of different kinds, but this particular one I set it you know, like 11 and 7 or 10 and 2, or not 10 and 2, but 10 and 7 or whatever. So you know, kind of opposing like that. And what I look for is when I come in that these touch at the same time. Okay, that's pretty close. So it looks like I'm just a shade high. Come in and I'm just coming up until the roller touches and starts to bite. Okay, and they're both biting. Free. Okay, so that's pretty good right there. So now what I'm going to do is shift slower speed, change the feed rate, back up. So that's 15 thousandths per rev feed. I'm going to come up and just touch, and then I'm going to note my my dial setting here. About 100 and about 100. Okay. So now I'm going to come off the part, come up to my dial, and then I'm going to dial in the first cut. So let's do, I don't know, let's do about 80, and 20, 30, 40, 50, 60, 70, 80. Okay. All right. And I like light lube, you know, kind of a watery, wet lube for this. Now I need 3/4 of an inch of knurl here. I got a lot of extra, but I got a little width on the tool. I got to, or the holder I got to deal with there. So hopefully I can get enough. I'm pretty sure I can. Okay, here we go. There it goes. And just keeping it wet. You don't ever want to check the feel of a knurl while it's running. It's just a bad idea. Okay, it's coming up nicely. Looks pretty good. I mean, from what I can see, I should say. Now I gotta watch this other side here, and I'm just gonna stop the machine when I'm where I think I want to be. Pretty good. All right, that's a gnarly knurl, huh? That's pretty good. You know, I could stop right there almost. You know, that's always the thing with knurling, right? You know, oh, one more pass, come on, just go for it, you know, and then you end up blowing the whole deal there, right? So, well, I'm gonna go one more. So we're 180. So let's see, I gotta do some math here. So that was 80, 90, 100, 110, 120. So I'm gonna go to 130 or 230 on the next one. All right, so disengage the feed. I'm going to come out, come back off. My touch off point. There's my next depth. Okay. I've engaged the rollers there. Hopefully I don't double imprint there. Let's go for it. So what I did was I just lightly came up to that corner and picked up the pattern. So it's kind of like gear teeth, you know. Now you can get it offset if you're not careful. And you'll end up with a knurl that's about or twice the fine. It's finer. And right there. Call it quits. Okay. Oh yeah, look at that. Sweet. Okay, so there's the knurl we just did there, and that's a knurl. That's a pretty coarse one there. Greg asked for a medium one, but this is what I had, so this is what he gets. So anyway, that's kind of a different way to knurl. Hopefully you guys got something out of that. Alright, so now we're going to use a little radius tool, a little form tool to put a radius on the end of that. And so here we go. So what I do here, just so you know what I'm looking at, is I'm looking at where this touches here. I don't want the corner to bite, so I'm just going to back off from it a little bit, and then I'm going to come up until I just see that scrape right there, okay? And then keeping it wet with the brush, I'm going to feed in Z now. That way I only have to look at one direction at a time when I'm using the form tool. What I don't want to leave is a hard line in there that's difficult to get rid of without going to a larger radius. This is a 1/8 radius here, about 3 millimeters for our metric viewers. And then, you know, with any broad cutting tool, you want to just go slow to make sure it doesn't chatter right at the last little bit, you know. And I'm just clearing the chips so I can see what the heck I'm doing there. And I'm getting pretty close now. I think I'm going to call that quits there. Okay, last operation on this is parting off, and we want to make sure we got plenty to he needs a precision thickness in the from this to the backside. So we're going to leave it long, and we'll turn it around and we'll put it in a collet and face that backside and measure that real carefully, and then dress this edge and then dress the other edge at the same time. So the goal here is just to knock it off, and with plenty of meat, which that should be fine, and just part this sucker off and get her done. Okay, so it's about 160 RPM, something like that. And this ought to be interesting with this camera here. I really want to get this in there like that so I can get some liquid in there. The goal is just to keep that groove wet, you know, and that way the chips flow out of there nicely. Hard to see, leaning over. I'm getting close now though. I'm gonna have to let go of the yeah, let's let go of that. Yeah, good. Okay, there's our product there. So yeah, I'll go back later on. And yeah, you see the knurlings kind of rolled some of that over there, so that'll come off with a little chamfer, and then we'll face this to thickness and we'll measure that carefully, and then add the same chamfer there, and then that's one of Greg's pins.